that we summarize data. There's also a concept called range. And range, as we've discussed in my class before, is when we take the highest number and we subtract the lowest number to find out the spread of the data. So can anybody tell me the spread of the data? 8, right. I don't always need people to raise hands. Sometimes I ask a question in such a way and we develop a rapport over time where you can tell when I'm sort of like, hello everybody, and they just can sort of respond, and sometimes it's a different type of question. So it's 8. So now I know that the middle of this is 6, and I know that the spread of it is 8. But the problem is that spread is the extremes. And again, if I go back to something like income, that spread is gigantic. And the middle doesn't feel like it tells me that much about the data. And the spread also doesn't feel like it tells me that much about the data. And so we have another way we talk about this. And if I had more than 5 minutes, I'd try to tease this out a little longer, but time being what it is. We want to find some way to understand the average, again, so we've got one, the mean, but we want to understand the average amount that we differ from the average. So the average amount we actually come off of the average. How spread out is the data? And this is a really interesting concept when you start to think about it. And I can tell you the students I talked to about it this year actually really got into the idea, because you end up in this place of realizing like, oh, the average amount we differentiate can say, well, if the average height of a person is 5'5", and the average amount that it varies is 3 inches, most people are going to be between 5'2" and 5'8". Those are made-up numbers, by the way. But they're going to be in this, and it tells you something about how spread out the data is. And as you get more and more extreme, there's a specific number that can tell us sort of how extreme the data is. It's called the standard deviation. Does anybody know, and now if you do know, you can share, but does anybody know how to find standard deviation? So, that's fine. That's fine. So, when we're talking about standard deviation, because it is the average amount that we switch, we end up still needing to find the average. I almost always try to go for the smallest piece of chalk I can find. So, we try to go with the amount it changes. So, if we have a mean value, that's 6. And we already figured out how to do that. When we go into standard deviation, we want sort of the mean amount that it varies, the mean deviation. So we end up looking at each piece of data. What's the difference here? Oh, the difference is 4. What's the difference here? Oh, the difference is 2. But these are actually below. Then the difference is 0. Then the difference is 2. Then the difference is 4. So we have this amount. This is now we know how much the data varies. And you can imagine if you're dealing with large pieces of data, technology helps. Like when you have a lot of data set, technology helps. But we can work with very small pieces of data to understand what happens in massive data sets. And so we have this, and we can find the average of this. But something weird happens if we do that. Something weird happens if we do that. If we add 2 and 2, what do we, negative 2 and 2, what do we get? 0. If we add negative 4 and 4, what do we get? 0. So if we add them all up, we get 0. That's going to be a bit of a problem. So we do this really fancy thing called squaring it. It's very fancy. We actually take the square variation here. We add all that up. We divide that by the number of numbers. And then we say, ha, just kidding, and we take the square root. So we basically square it, we make it bigger, and then we shrink it back down later after we've done the calculation. And the advantage of that is that when you square things, you're no longer going to have these negative numbers. So we sort of inflate the difference for a time, but we're going to undo that later. And what ends up happening is we can still get the average by like mathematically fudging it for a moment. And what we end up with is this really interesting idea of the average deviation from the average, which, by the way, mathematically, I don't care what data set you use, the deviation will always add to 0, because that's what mean does. That is the middle, and so it's equally out from the middle. It's the middle. And so you're always going to end up with that. You need to do something mathematically, and what you do is you get the standard deviation, which then you can dig into in data sets to not only understand, well, what's the average American earn, but also how much it deviates. Because if you said the average American earns $40,000 a year, I have no idea what the number is, but $40,000 a year, and the standard deviation is $100, you're like, wow, almost everybody makes pretty much the same amount. And if you say it's $40,000 a year, but the standard deviation is $2 million, you're like, well, you've told me almost no information whatsoever. Because it gets so broad, you know almost nothing about it. So that's, like, again, real quick, we take a few days to go over and really try to not only understand the mathematical process, and I could write a formula on the board, and I could talk about how it's different if you use populations and samples and things like that. But the idea is what I really want the students to walk away with. The idea that we can use math to understand large groups of data, we can summarize in a meaningful way, and a way that is sort of mathematically consistent. So if I say that I am 2 standard deviations above the mean in my volleyball skill, and I'm going to tell myself I am, and we say you are 2 standard deviations above the mean at dancing, because I've seen you dance. So if we say you're 2 standard deviations above the mean at dancing, we understand that, like, actually we're equally better at the things that we're doing compared to the average amount. It even lets us compare across disciplines. So I think it's a really neat idea, and it's sort of connective and understanding of large sets of data, and holy cow, there's so much data in the world. So it's really helpful to occasionally be able to summarize it. So that's the mini lesson. I probably took more time than I was supposed to. I get into it, and then, the bell rings, and I'm like, oh, we'll pick this up tomorrow. But there's no bell to stop me. All right, so let me talk about math overall for just a moment. And as you can tell, I get really into it. I think it's a lot of fun. And I think it's fun in a way that the students also tend to pick up on. Now, they roll their eyes and grumble aplenty, but less than they might otherwise. So, and I know that because I've done a lot of research. So anyway, math overall, we do want to develop their skills. We want to develop their skills over time, and we want them to be able to have the skills they need if they want to go into sort of complex mathematical disciplines. So we have an arc that's going to help develop those specific skills to get you there, but we also want to develop problem-solving abilities. And so that question of, when am I ever going to use this? It comes up all the time. And sometimes I tell them, well, like this. And sometimes I say, well, what you're actually learning is problem-solving, and a different way to think, and attention to detail, and I promise you these things will matter. So even if you never use this specific thing, there's an element of problem solving, this abstraction of thought that math can bring that can help problem solving, and even things like word problems and so forth. I tend to, with new concepts, try to get the students to see the process before I explain it. And when I say I mean sort of Waldorf, but I'm using me as the example here. So instead of just saying, when I taught this lesson to them, I asked them to figure out how you get the average of averages. And they were like, well, you add it all up. And I was like, ha ha. And they go in and they get the 0 and they're like, well, that's a problem. And I was like, try it with a different data set. And they're like, it keeps happening. And we get to discover this thing and, how do you think you do it? And they come up with different ways. And by the mere act of thinking about it, before I say, oh, by the way, we've already solved this, they're way more likely to understand my answer. And then they're going to forget it, and we're going to do it again, and we're going to drive it in over time, right? Because everybody's going to forget things. So it's important that we bring things back, and we're not worried about how much it lives in you the first time, but at the end we want it to live in you. So even if you can't quite remember how to do it, you always remember what standard deviation is, right? So we largely focus on algebra and things like building up towards calculus. We do a lot of geometry, and we do statistics. Those are sort of the three big things that we're focusing on overall. 7th grade is when you begin algebra. Mr. Kimberly, who has now arrived, hello Mr. Kimberly, is, I know, doing a bunch of statistics with the 7th grade. Well, not as we speak, but like currently. And 8th grade, we do things like number bases to try to better understand our mathematical system, because we don't need to use numbers the way we use them. And sometimes looking at a different way to do it can help you understand the way we do it. So we do that. We get into more geometric ideas. We talk about the Pythagorean theorem in more depth. We try to drive these home. And then when we get into high school, our 9th grade is really the quadratic formula. We have permutations and combinations. We have descriptive geometry. Then when we go into 10th grade, we start the basis of trigonometry. We do some matrix algebra. We get into, well, I was going to say more geometry, but that's really the trigonometry. We do some other things to make sure those skills stay strong. We do more with logarithms, things like that. When we go into 11th grade, we're further developing trigonometry, giving more skills there, more algebra skills, making sure they're prepared for calculus, but that's also where we do things like projective geometry, which was spoken about, and things of that nature. So we're trying to keep this wide-ranging. Standard deviations, like I said, we already covered. In 11th grade, we try to get into more statistical ideas like confidence intervals and things of that nature. And then in 12th grade, we do teach calculus, but we also try to go into things like hypothesis testing from statistics. So we try not to just say like, well, it's this way. We try to keep it fairly broad. And by now, I'm sure I've gone way over my time. So I am going to stop and let us move on to the next thing. But I promise after the questions, if you have specific mathematical questions for me, I will hang out after and you can ask me because I can ramble.